Hello friends, how are you? I hope you all are good. Now in previous class we studied simple salts. So that simple salt further we classified into neutral, acidic salts, basic salts. Okay. So now it's time to study our next. Okay, that is what your double salts. Okay. So see here, double salts. So what is double salt? So this itself name indicates what they indicate double means it contains two cations and your two anions also present. It can may present. Okay. So here double salt. So first we will discuss what is the definition of this double salt. Okay. So these are addition compounds. So see here these are addition compounds. Okay, these are addition compounds formed by two or more stable formed by two or more stable two or more stable compounds join join together join together in stoichiometry join together in stoichiometric composition, okay, or you can say in stoichiometric amounts in which they lose their identity in solution, in which they lose their identity in where? In solution. If you dissolve in that water, so what will happen? It will lose their identity in solution. That is what your double salts. So see here example, better examples we will discuss here. Potash alum. First example is what? Potash alum. So you must know here a formula of your potash alum. Okay. Double salts, mean two cations are present. K2SO4 dot Al2 here Al2SO4 thrice dot 24H2. These are what beta your complete potash alum. Okay. Next, more salt. Next what beta here? More salts. So basically more salt is iron ammonium sulfate. What beta? Iron ammonium sulfate. So see here their formula FeSO4 dot NH4 twice SO4 dot 6H2O. Okay, these are what beta? More salt. Understood? So these are some examples of what? Double salts. So these are what compound formed by two or more stable compounds joined together in stoichiometric amounts or in their composition in which they lose their identity in solution. Suppose if you dissolve in this water, so whatever their original identity they will lose. Understood? So these are what basically double salts. Now we will move towards next, that is complex salts. What beta? Complex salts. So see here what will be here complex salts. Complex salts. So name itself indicates complex salts. So beta these are also addition compounds. Okay, addition of compounds that formed by two or more compound. It must be joined together in their stoichiometric amounts. Okay, which retain their identity in. So one more here most important difference is what? Basically definition is same as like a double salt, but here after joining in their stoichiometric amounts, okay, whatever these compounds, whatever these salts, okay, retain their identity, retain their identity in solid state, as well as, okay, as well as in solutions. In solutions. For example, see here. For example, potassium ferricyanide. Potassium ferricyanide is available in our chemistry lab. Potassium ferricyanide. So see here, formula as like this: K3FeCN6. Coordination compound it is. This coordination compound topic, it is in higher standard, in 12th standard. Coordination compounds. Okay. Potassium ferricyanide. Okay. It is also, and one more also available, same. See, potassium ferrocyanide. So say potassium ferrocyanide. Say as like this. Their formula, chemical formula is like this: K4FeCN6. K4FeCN6. Understood? So here, ferri means whatever your iron in +3 oxidation number, and potassium ferro means whatever your iron in +2 oxidation number. Okay, we will see one more examples in your complex salts. Okay, so basically difference in their definition is what? Whatever your double salt, they lose their identity in solution, but here they retain their identity in solid state as well as in molten state, in solution state. Okay, so we will discuss here one more example. Okay, hexamine cobalt trichloride. What beta? Hexamine cobalt trichloride. Understood? So beta, it is what basically another IUPAC system for inorganic compounds. So inorganic compounds, what beta? In that inorganic chemistry coordination compounds we are going to study. Okay, in next standard. In higher standard, in 12th standard. Okay. So what will be the, see the formula for this beta? CO NH36Cl3. Okay, so like that. So very much important all these coordination compounds. Okay, now we will move towards last whatever types of salts, that is mixed salt. What beta? Mixed salts. So say here we will say that also, mixed salts. So mixed salts, so what will happen of these salts? So these salts which contain, so say we will discuss a definition. These salts, okay, which contain more than one type of, contain more than one type of, more than one type of acidic or basic radical, acidic or basic radical, and that acidic or basic radical which may be your, okay, diacidic, dibasic, which may be your dibasic or tribasic. Understood? Okay, so with whatever these compounds, it will form with monoacidic basis also. Understood? So for example, we will discuss whatever definition we saw mixed salts, the salts which contain more than one type of acidic or basic radicals. It may be dibasic or tribasic, or it may be your monoacidic, diacidic basis also. Okay, so we will discuss, for example, sodium potassium carbonate, okay, mixed salt. One more here salt, That is CaOCl2. CaOCl2 is what? Yes, bleaching powder. What beta? Bleaching powder. Okay. Disodium potassium phosphate also there. So see as like this. Na2KPO4. Disodium potassium phosphate. Okay. Zinc hydroxide chloride also possible. Zinc hydroxide chloride. Okay. These are what examples of all. So we can write like that. Mg magnesium hydroxide chloride also it will possible for your mixed salts. Okay, so these are what beta? Mixed salts. So we covered whatever all types of salts here. Okay, now we will move towards preparation of salts. Okay, now we will move towards what? Preparation of salts. So say here preparation of salts. So see here in preparation of salts. Now we will discuss first preparation of soluble salts. What beta? Yes. Preparation of what? Soluble salts. So preparation of soluble salts. In that, as you know, beta, direct combination with the help of direct combination of elements by heating also we can prepare such type of salts. So we will take here one example. Direct combination. Okay, so say direct combination of elements by heating. So see here, iron plus Cl2 that gives what beta? Yes, obviously what will happen? FeCl3 to balance this reaction. So see 2Fe, 2Fe, yes, 3Cl2. So our reaction is balanced. Understood? Or we can form by simple displacement also. So see simple displacement how we can prepare that simple salt. So see iron plus HCl. So what you will get? Yes, FeCl2 plus what? H2 gas will release. Okay. So for balancing, take here 2. Okay, so say iron, Cl2 into hydrogen gas will release. Okay. Now if you are going to discuss third, by decomposition of carbonates or bicarbonates, by acids. Okay, so see here, by decomposition of carbonates. Okay, so say by decomposition of carbonates. Whatever I am saying that you have to write, and after writing this reaction you have to complete. Okay, with a balanced. Okay, by decomposition of carbonates and bicarbonate by acids. So say here we will discuss first sodium bicarbonate NaHCO3 plus. So suppose if you are taking HCl, so what will happen beta here? Yes, your salt will generate. Okay, NaCl salt will generate beta. If you can observe here breaking also. So see Na plus HCO3 minus. Yes, H plus Cl minus. So old bond will break, new bond will form. So what we will get? H2CO3, and that H2CO3 we can write in this fashion. How? H2O plus CO2 together we call what? H2CO3. That is what? Carbonic acid. Understood this? Okay. So these are what beta? Your soluble salts. One more also we can write fourth example. Okay, so say that fourth example. Suppose if you are considering, now only we saw carbonate, bicarbonates we saw. Now suppose if you are considering here only carbonate. So see cupric carbonate. So as I told already, cupric means +2 and cuprous means Cu +1. Okay, so see fourth one we will discuss here. CuCO3 plus HCl. So what you will get? Yes, immediately you will get what? CuCl2 plus H2O plus CO2. Okay, understood this? CO2 gases will release. Okay. Now to balance this, so say here 2 hydrogen. Yes, Cu, 2 Cl. Okay, carbon also 1, 3 oxygen. Yes, our reaction is balanced completely. Understood? So these are what we prepare here. Prepare some soluble salts. Okay, preparation of soluble salts we done here. Now it's time to discuss preparation of insoluble salts. So we will move towards insoluble salts. Preparation of insoluble salts. So see how it will we will prepare this insoluble salts. Okay, by direct combination. First we will discuss by direct combination of the whatever your acidic oxide or basic oxide. So see, as you know, acidic oxide, suppose I will take here example of this SO2. SO2 is what? Acidic oxide. These are what beta? Acidic oxide. And CO is what? Basic oxide. We are using this in flux. Okay. In metallurgy. So what will happen beta? Ca. Yes. CaSO3. CaSO3. Calcium sulfite. What you will get here? Calcium sulfite you will get here. Understood? Okay, so these are what beta, whatever we discuss here, direct combination. Okay, now by double displacement also we can prepare whatever your insoluble salts, and that insoluble salts we can observe with the help of what? Precipitate, in the form of precipitate. Okay, so see here, suppose if you are taking lead nitrate. Okay, so see here, whatever second example in our, yes, second example in insoluble salt, by double displacement. By double displacement, how we can see here? Okay, lead nitrate, as you know, PbNO3 twice plus Na2SO4, sodium sulfate, both are in aqueous. Okay, beta, insoluble salt we have to prepare. Then you will get what? PbSO4. Okay, cation anion they will attract, plus minus NO3 minus, here what? Plus and minus. So you will get what here? PbSO4 precipitate, here you will get plus, yes, plus what beta? 2NaNO3. See here, our reaction also balanced sodium nitrate you will get. And whatever next reaction that you can discuss in whatever these also reaction, all reaction, whatever whichever possible, that we will discuss in chemistry lab also. Understood? Now we will take here some common example. As you know beta, precipitation reaction. Okay, if you are taking silver nitrate solution and HCl. Okay, so see, precipitation also it will occur. Third, suppose if you are discussing AgNO3 plus AgNO3 aqueous. Okay, plus here, as you know beta, NaCl aqueous. Okay, so what will form here? Old bond will break, new bond will form. Cation anion they will attract, and you will get what? AgCl. AgCl solid. See, breaking plus minus. Here also plus minus, plus they will attract here. Okay, and this will attract. So white precipitate here you will get plus what? NaNO3. Okay, understood? So these are what? Some precipitation reaction. Means here we are preparing what? Insoluble salts. What beta? Insoluble salts. Now see here, we will discuss one more here important part, that is some important salts we will discuss. Okay, some important salts. In that, some important salts, say some important salts. So see, in some important salt we will discuss first that is sodium chloride. What beta here? Sodium chloride. So basically sodium chloride, this what we can call as a common salt. Common salt also we can call. Okay, table salt, rock salt. Okay, it is basically neutral salt. Understood? Why it is neutral salt? Because it will prepared by strong acid and strong base. NaOH plus HCl. NaOH is your strong base and HCl is what? Strong acid. That's why whatever this sodium chloride, we can also call what beta? Rock salt. Okay, whatever that rock salt is, where so much impurities are present in that. Okay, and what? Neutral salt. Neutral salt. Okay, so see here, whatever your initial, now we will discuss. Okay, so lab preparation. So in that we will discuss beta lab preparation. Lab preparation of this what? Sodium chloride. So in laboratory, how we can sodium chloride can be obtained by the reaction of, yes, reaction of what? Sodium hydroxide with HCl. Okay, so now only I discuss, it will prepared by what? Strong base, strong acid, NaOH aqueous plus HCl aqueous. So what we will get? Yes, NaCl solid we will get. Okay, so for it beta, first we will get aqueous only, plus what? H2O in liquid form we will get. So whatever that NaCl, whatever in aqueous, you have to evaporate that, and after losing of water, you will get what? Solid reappears. Okay, so these are what? Preparation of lab preparation of your this sodium chloride. So whatever next point that we will discuss in next lecture. Okay, thank you.